In this video, I'm going to be explaining how to solve a system of linear equations in two variables using substitution. Now, you may have seen in a previous video me solving these exact same systems of equations, but using elimination, in which case you would know how they work out. But regardless, let's pretend we don't know what the solutions are and approach them via substitution. So first things first, I'm going to approach this system. A system is just a list of equations. So this system has two equations and two unknowns, x and y, two variables, and I'll label these as A1 and A2. Now, the way substitution works is that you solve one of the equations for one of the variables, and you substitute it into the second equation, or the first. You can solve either equation. It doesn't really matter as long as you do all the algebra correctly. One may be simpler than the other, but sometimes that's a lot harder to see with substitution, so I wouldn't stress too much about that. So I'm looking at equation 1. I could solve this for either x or y, and I really don't see any way in which either one is easier or makes more sense. So I'll just solve it for y because I feel like it. So when I say solve for, what that means is get that variable by itself. So I write down, just rewriting it, 2x plus 3y equals 6. I want to get the y alone, so I subtract 2x from both sides. And I get 3y is equal to negative 2x plus 6, or 6 minus 2x, same thing. And then I solve for y by dividing everything through by 3. This gives me y is equal to negative 2/3 x plus 6 over 3 is 2. So this is from equation A1. As long as you do all the correct algebra, this is the same equation as that. Nothing has changed. I've just rearranged things. And so now I'll take that and I'll plug it into equation 2. So equation 2 is 5x plus 9 times y. But what's y? Well, it's negative 2/3 x plus 2. And that is why this is called substitution. I'm taking what the variable is in terms of the other equation and plugging it into the second equation. Okay. So now I just simplify this. 5x plus, well, 9 times 2/3. I'll write that out. 9 times negative 2 over 3, I suppose, if you like. I'll write this out explicitly. Plus 9 times 2 is equal to 14. The 3 is going to reduce with the 9 here and give me 3. So I have 5x 3 times negative 2 minus 6x plus 18 is equal to 14. So I need to solve for x. Let me combine like terms. 5x minus 6x is minus 1x. And let me move the 18 over by subtracting it. So I have minus x is equal to negative 4, which means, of course, if I divide both sides by negative 1, that I get x is equal to 4. Now, what's nice about substitution is that once you've got one of the variables, in this case x, it's actually a little bit easier in this method to solve for the other because you already did. You have what y equals in terms of x here. So I can just plug the x in. Y equals negative 2/3 times x, which is 4, plus 2. Although I have to do a bit of work to simplify this. This is negative 8/3. Well, when you add two equations, the denominators have to match. So I rewrite 2. It's 2 over 1. Multiply top and bottom by 3. So this becomes 6 over 3. And when I do that, I get negative 8/3 plus 6/3 is negative 2/3. And that's my solution for this system of equations, 4 and negative 2/3. Once again, it means you've got two lines. Perhaps one looks like this, and perhaps one looks like this. And you're asking where do they intersect? And in this case, would be there at 4, negative 2/3. So that's substitution with the first system. And again, if you saw the video with elimination, I got the same solution as we would expect, just by a different method. Now, let me use substitution again, but with this equation. Once again, I'm looking at this, and I really don't see it being any simpler to solve for one variable over the other. So I'll just arbitrarily decide to solve the first equation for x. So first, I subtract the 7y to both sides. So I get 3x is equal to negative 7y plus 1. And then I divide through by 3, so x is equal to negative 7/3 y plus 1/3. And then what do? I take this and I plug it into the second equation. 9 times negative 7/3 y plus 1/3 plus 21y is equal to 6. And then I simplify this. This becomes multiplying into 9. Think of this as 9 over 1. So this becomes negative 21/3 y plus 9/3 plus 21y equals 6. Well, 9/3 is just the same thing as 3, and 21/3 is the same thing as 7. So negative 7y plus 3 plus 21y equals 6. Let me combine like terms again. Negative 7y plus 21y is going to be 14y. And then if I minus the 3 on both sides, I get that this is equal to 3. So y is equal to 3/14. Well, this is interesting because you may have seen in the previous video that when I go through this, I get no solution. But I've got a number for y. Y is 3/14. But I'm not done because I need to find out what x is. So I plug this in. I get that x is equal to negative 7/3 times 3/14 plus 1/3. Well, this simplifies a good bit. 3's cancel, the 7 cancels with the 14 and gives me a 2. So I've got negative 1/2 plus 1/3, which I simplify. X is equal to negative 3/6. Remember, the denominator needs to be the same. So 3/6 is the same thing as 1/2, plus 2/6 is the same thing as 1/3. And so I get x is equal to negative 1/6. So what's going on here? I'm getting a solution. X equals negative 1/6, and y equals 3/14. But if you do substitution, you have to realize that you need to check that this point here satisfies both of these equations. In other words, you need to make sure it actually works. So if I try it in the first equation, if I try this in the first equation, I get 3 times negative 1/6 plus 7 times 3/14. And this should equal 1. Well, let's see if it does. 3 by negative 1/6, that just gives me negative 1/2. The 7 here reduces with the 14 and gives me 3/2. So I've got 3/2 here. And negative 1/2 plus 3/2 is 2/2, which is indeed 1. This works for the first equation. What about the second equation? Well, if I plug this into here, I get 9 times negative 1/6 plus 21 times 3/14, and this should equal 6. Well, let's see if this works. The 9 times negative 1/6 becomes negative 9/6, which is negative 3/2. The 21 and the 14 are both divisible by 7, which gives me 2 and 3. So this becomes plus 9/2. And 9/2 plus negative 3/2 is 6/2, which equals 3, which does not equal 6. So because I did all my algebra correctly, but I got a point which only worked for one equation but not both, this one would have no solutions. Okay. Now I seem to have used up quite a bit of the board, so the video is going to fast forward at this point while I erase to make room for this one right here. Be right back. Okay, so now that I have some room, let's go ahead and tackle this last equation. I'll call this C1 and C2, although the B equations are now gone. And same idea, I'm going to solve for one variable and plug it into the other. Eyeballing this one here, I think I'm going to solve for y because it has the smaller number. But again, this is just an intuitive thing. Don't worry too much about where I'm getting that from. So let me solve this equation for y. So to do so, I'll subtract the 10x from both sides. So I get that 5y is equal to negative 10x plus 15. And then to get y by itself, I divide everything through by 5. And so I get y is equal to negative 2x plus 3. Again, that's from equation C1, and I'm going to plug that into equation C2. And so I have 20x plus 10 times my y here, which is negative 2x plus 3. And that should equal 30. Let's see what happens. Distribute the 10 in here. I get 20x minus 20x plus 30 equals 30. Huh, my x's cancel out entirely, and I'm just left with 30 equals 30, which is true. It's trivially true. When this happens, again, assuming all your algebra was correct, when this happens, we know right away that there's an infinite number of solutions. In other words, the fact that this equation equals this and this equation equals this has nothing to do with what numbers you pick. You could pick any 2 points on the lines and they'll intersect. What that means is you've got one line here, and here's your other line directly on top of it. So with substitution, it's pretty straightforward that you'll have an infinite number of solutions because your variables will just cancel out and you'll get an obviously true thing, 30 equals 30, which if you subtracted 30 from both sides, you'd have 0 equals 0 if you want to always go down to that form. And so there we go. Those were 3 different systems of equations in 2 variables and how you can solve them by substitution, assuming there is a solution, and how you can interpret what's happening if you get an infinite number of solutions or no solution at all. Notice that for no solution at all, though, to recognize that that's happened, you do need to check your point in both equations. And so actually, I should have checked this point in both of these equations here. I didn't do that because I made these questions and I know that this is the solution to this. But as you saw with the no solutions case, you should always take your answer and plug it into both equations and make sure that both of them check out. And that was this example.